Hello everyone. In today's video, we are going to solve more questions on constant velocity problems. Let's get started. Find the position vector r of an object when its initial position A and the velocity v is given to you. Consider a boat sailing with the velocity 3 minus 2 km per hour. At 12 hours, the boat is at the point A with the position vector 313 km relative to an origin. Now the diagram shows that the position vector of the boat 12 hours, 1 pm, 2 pm and 3 pm. As you can see it here, this is our diagram. This is at 12 hours, this is at 1 pm, 2 pm and 3 pm. How we are getting the coordinates of this one? So this is the initial position you have and you are moving with the velocity 3 minus 2 km per hour and you are traveling from 12 hours to 1 pm. So the time taken is only 1 hour. So 1 hour you are moving with the velocity of 3 minus 2 km per hour. So the velocity vector at 1 pm will be given by your initial position, which is 313, plus your velocity vector, and the velocity vector should be multiplied by the time. So you are moving for 1 hour. So this will be multiplied by 1. So if we solve it here, this will be 3 plus 3 and that will be 13 minus 2. So if you solve it, that will be 6, 11. So as you can see here, we have plotted the point at 6, 11. So after 1 hour, you will reach at this position. Now the position vector at 2 pm. So from 12 hours to 2 pm, you are covering 2 hours. So this is the initial position. This is the velocity vector. And with this velocity, you are moving for 2 hours. So that number should be multiplied by 2. So if you solve it here, that will be equal to 3 plus 6. And that will be 13 minus 4. So if you solve it, that will be 9, 9. So as you can see here, we have reached 9, 9 after 2 hours. So the position vector at 3 pm, this is your initial position, plus this is the velocity vector, and with this velocity you are moving it for 3 hours. So that will be multiplied by 3. If you solve it, that will be equal to 3 plus 9 and 13 minus 6. So that will be equal to 12, 7. Hence, the position vector r of the boat t hours after 12 hours is given by the expression. This is the vector. You are going to find it out. So that will be equal to the initial position A plus the velocity vector is v, and that should be multiplied by the time. So if an object has initial position A and moves with a constant velocity v, the position vector r at time t will be given by the formula. The r vector is equal to the initial position plus t times the velocity vector. Now let's see one example. At 12 hours, a ship leaves a point Q with position vector 10I plus 38j km relative to an origin O. The ship travels with velocity 6I minus 8j km per hour. First, find the speed of the ship. Second, find the position vector of the ship at 3 pm. Third, find the position vector of the ship t hours after leaving Q. Find the time when the ship is at the point where the position vector 61I minus 30j km. So first we have to find out the speed. As you know that speed is equal to modulus of the velocity. What is our velocity? Velocity is 6I minus 8j. So that means we are doing modulus of 6I minus 8j. So that will be solved as root of 6 square plus minus 8 the whole square. So if you solve it, that will be 36 plus 64, which is equals to root of 100. That is equals to 10 km per hour. So that will be your answer for the speed. Now we have to find out the position vector of the ship at 3 pm. You have started at 12 hours and you reached to 3 pm. That means you have traveled for 3 hours. So From 12 hours to 3 p.m. the time is 3 hours. So the position vector of the ship is the initial position, which is 10:38, plus the velocity vector is 6 minus 8. That should be multiplied with the time. The time is 3 hours. As you can see that I have substitute here. So now we have to solve it. So it will be 10:38 plus that will be 6 times 3 is 18 and 8 times 3 is minus 24. So 10 plus 18, 38 minus 24. So that will be equal to 28 and 14 kilometer. That will be your answer for the position vector of the ship. Now we have to find out the position vector of the ship t hours after leaving Q. So this is the initial position. This is the velocity vector. We have to find out the position after t hours. That means I have to multiply this with time t. So if I solve it here, that will be 10:38 plus it will be 6t minus 8t. If I join it, it will be 10 plus 6t and it will be 38 minus 8t. That will be your answer after t hours. Now we have to find out the ship's position vector is given to us is 61i minus 30j. As you know that this is the position of the ship after t hours. So this is given to us as 61i minus 30j, and then from here we have to find out the time t. So I can equate both of them. So as you can see that I have written it in the column vector form and I have equated both of them. Now I can compare the I vector separately and j vector separately. If you can equate the j vector or the I vector separately, you will find out the same answer. So I'll do it with only one of the methods. So if I equate the j vector, minus 30 is equal to 38 minus 8t. Move this 38 on other side. It will be minus 8t is equal to minus 30 minus 38. Minus 8t is equal to minus 68. Minus will got cancelled from here. T will be equal to 68 over 8. If you solve it, t will be equal to 8, 1.5 hour. So 8.5 hours after 12 hours is 8:30 p.m. So 8:30 p.m. will be written as 2030. At 15 hours, a submarine departs from a point A. So this is the point A. From here, the submarine has started. So and travels a distance of 120 kilometers to the point B. The position vector r kilometer of the submarine relative to an origin O t hours after 15 hours is given by the vector r is 15 plus 8t and 20 plus 60 in the column vector form. Now first we have to write down the position vector of the point A. Second, we have to write down the velocity vector of the submarine. And third, we have to find out the position vector of the point B. Now, as you can see that they have given us the position vector of the submarine after t hours. So, if it is possible for me to split this in the form of the position vector and the velocity vector. So, how do we do that? This can be written as 1520 plus 8t and 6t. So that will be equal to 1520 plus t is common from here. So that will be 8, 6. So as you know that this is our initial position and this is our velocity vector. So our first question is the position vector of the point A. So the position vector of the point A, the starting position is 1520. So the position vector of A will be given by 1520. That will be your answer in kilometer. Now I need to find out the velocity vector. So as you know that this is our velocity vector. So velocity vector will be equal to 8, 6 kilometer per hour. Now we need to find out the position vector of the point B. So the position vector of the point B, I need to find out the time. As you know that time is equal to distance over speed. I need to find out the speed. Distance is already given to us. It is 120 kilometer. Now, as you know that the speed is equal to modulus of the velocity. So, velocity vector is mod of 8i plus 6j, which will be equal to root of 8 square plus 6 square is equal to 64 plus 36, which is equals to root of 100. That will be equal to 10 kilometer per hour. So our time is given by distance is 120 over speed. Speed is 10 kilometer per hour. Let's put it here. Now 0 will got cancelled from here and your answer will be 12 hours. Now I need to find out the position vector of B. Position vector of B is the initial position plus the time, which is 12 hours, and the velocity vector. We need to solve this. So if I solve it, it will be 1520 plus 12 times 8 is 96, 12 times 6 is 72. So I need to add that 15 plus 96 and it will be 20 plus 72, which will be equal to 111 and 92 kilometer. That will be our position vector of B. Let's see one more example. At 12 hours, two boats A and B have position vectors minus 10i plus 40j kilometers and 70i plus 10j kilometers. So this is the position vector of A. Initial position is minus 10, 40, and this is the position vector of B, which is 70, 10. And they are moving with the velocity 20i plus 10j kilometer per hour and minus 10i plus 30j kilometer per hour. So the A is moving with the velocity of 20, 10, and B is moving with the velocity of minus 10, 30. Find out the position vector of A and B at 15 hours. Find out the distance between A and B after 15 hours. So after 15 hours, they are reaching at A dash and B dash. So I need to find out this distance. So first I need to find out the position vector of A. To find out the position vector of A, I need the initial vector, which is I have the velocity vector. Only thing I need the time. So from 12 hours to 15 hours, you traveled 3 hours. So the position vector of A is the initial position plus the time and the velocity vector. So the time is 3 hours. Let's put the value here. That will be minus 10, 40 plus 3, 20, 10. So if I solve it, that will be minus 10, 40 plus 60, 30. You have to add it, minus 10 plus 60, and that will be 40 plus 30. So that will be equal to 50, 70 kilometer. That will be your answer for the position vector of A. Now I need to find out the position vector of B. So this is the initial position of the B plus the time multiplied by the velocity vector, and the time is still 3 hours. So I will be substituting here 70, 10 plus 3 hours minus 10, 30 velocity vector. So that will be 70, 10 plus minus 30, and that will be 90. So 70 minus 30, 10 plus 90. So that will be equal to 40, 100 kilometer. So that will be your answer for the position vector of B. Now as you can see that they reached here at the positions of A dash and B dash after 15 hours. Now I need to find out the distance between A dash and B dash. To find out the distance, this is the vectors. So I need to find out the first vector A dash B dash. So the A dash B dash, if I write down in the position vector form, that will be written as OB dash minus OA dash. OB dash is 40, 100 and OA dash is 50, 70. So I need to solve it. That will be equal to 40 minus 50, and it will be 100 minus 70. So that is minus 10, and this will be 30. Now I need to find out the distance. So the distance is equal to mod of minus 10i plus 30j. I am doing the modulus of this vector. So that will be written as root of minus 10 the whole square plus 30 square, which is equals to root of 100 plus 900. That will be equal to root of 1000, which will be written as 10 root 10. That is equals to 10 multiplied by, if you find out root 10, that will be equal to 3.16 approximately. So if you multiplied it with 10, your answer will be 31.6 kilometer. That will be your answer. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.